Hi everyone, this is Maverick Paul, the chemistry guru. Now in this video, we want to discuss the suggested solution for 2021 A-Levels H2 Chemistry, Paper 1, Question 14. So question 14, I have compound Z is used in perfumes to give a fragrance of sandalwood or musk. It can be reduced by hydrogen gas with a nickel catalyst to form compound Q. So the compounds for Z and Q, they're all given. The question is asking how many stereoisomers exist for Z and for Q. We have 4 options A, B, C, D, and we want to determine which is the correct answer. Now, involving stereochemistry, the topic tested in this exercise will be Introduction to Organic Chemistry under isomerism. So maybe what we can do is we can do a very brief overview involving stereoisomers. In syllabus, we have 2 types of stereoisomers, Cis-trans isomer. Usually we target this for alkene, and optical isomers, where we look out for a chiral carbon, saturated carbon, or an sp3 carbon bonded to 4 different groups. Now if I take a look at cis-trans isomerism, what is the criteria for my alkene to exhibit cis-trans isomerism? Now for alkene, we have 2 carbon. Each of these alkene carbon must be bonded to 2 different groups. My alkene carbon on the left hand side must be bonded to 2 different groups, in this case X and Y. My alkene carbon on the right hand side must be also bonded to 2 different groups, X and Y. Of course, all the 4 groups that is attached to my alkene carbons can be different, but the criteria is each alkene carbon must be bonded to 2 different things. Then the group which is bulkier in terms of size, we will highlight them and we will see where are the bulky groups. So if the bulky groups, they are on the same side, so you notice the bulky group and the C double bond C and the other bulky group, it forms this C here, then this is our cis isomer. And if I consider the bulky groups, if the bulky groups are on opposite sides, this will be the trans isomer. And this is how we identify your alkene that can form cis-trans isomerism. Now how about optical isomerism? Optical isomerism, again what we look out for is a chiral carbon. Chiral carbon is a carbon bonded to 4 different groups. And if I have a sp3 carbon bonded to 4 different groups, then we will expect that chiral carbon, the mirror images of each other, they are non-superimposable. So they are actually different things, and we call them optical isomers or enantiomers. So for this question, since we are given the skeletal formula for your compound Z and Q, maybe what we can also do is we can go through what are the types of carbon that we can focus on. Usually what we need to do is we just need to focus on these 2 types of carbon, carbon bonded to 3 groups and carbon bonded to 4 groups. Now remember, when we draw skeletal formula, when I have a specific carbon that looks like this, look like it is bonded to 3 groups, there's actually a hidden hydrogen that is not shown, and therefore this carbon is actually bonded to 4 groups. And we also look out for carbon bonded to 4 different things. Usually these 2 guys will be chiral. Of course, what we have to look out for is maybe carbon bonded to 4 groups, but 2 of the groups are identical. But these are the 2 carbons that we focus on, and the rest of the carbon, we can actually safely ignore. This carbon, the yellow carbon that I'm highlighting, we can ignore because this is a CH2, and if you have 2 hydrogen, it will not be chiral. I need a chiral carbon to be bonded to 4 different groups. Benzene carbon we can ignore because benzene carbon is only bonded to 3 groups, and therefore it can never be chiral. Alkene carbon we can also ignore because alkene carbon, same thing, it is not bonded to 4 different groups, only bonded to 3 groups. It can never be chiral. And you notice when we look at our organic compounds in questions, the compound usually is asymmetrical. So when you look at this compound from left to right, there's no obvious mirror plane. So if this is true for Z and Q, then we can actually safely use this guideline here. I just need to focus on these 2 types of carbon. Carbon bonded to 3 things, almost always the case, this guy will be chiral. Carbon bonded to 4 groups, most likely this is chiral, but look out for 2 of the groups being identical. So with this in mind, now we can take a look at compound Z and Q and try to identify whether each of these guys has a cis-trans alkene and a chiral carbon. Now involving compound Z, first thing let us talk about alkene. Now I have 2 alkenes here. Now this alkene, it is a cycloalkene. And cycloalkene in general, there's no cis-trans isomerism because of the ring strain. Some of us might identify this as the cis isomer, but I cannot draw the trans isomer for this compound because the cyclo group or the ring structure actually makes the trans isomer highly unstable because of the twisting of the carbon-carbon bond due to the cyclo configuration. So in syllabus, usually when we consider cycloalkene, there's no cis-trans isomerism. There's no need for us to consider cis-trans isomerism for cycloalkene. Now, how about this yellow alkene that we've highlighted? Now, you notice this yellow alkene, this carbon at the bottom is bonded to a hidden hydrogen and an R group on top. This other alkene carbon is bonded to a CH3 and a CH2 OH group. So this alkene carbon is bonded to two different groups. The other alkene carbon is also bonded to two different groups. And this means that my yellow alkene that we've highlighted will be able to exhibit cis-trans isomerism. I'll have one cis-trans alkene. Now next, how about chiral carbon? Now chiral carbon, if you keep in mind, what we need to look out for is carbon bonded to 3 groups or carbon bonded to 4 groups. Now there's only one chiral carbon here. This carbon that we've highlighted in blue is bonded to 3 things. Remember, there's a hidden hydrogen. So this guy is actually bonded to 4 different groups. This carbon will be chiral. Now if I take a look at the green carbon here, now this green carbon is bonded to 4 groups, but 2 of them are identical. I have 2 methyl groups. So this green carbon, we will take a look at this guy, but it turns out to be non-chiral, so we can ignore this chap. So if you take a look at the rest of the carbon, they are all non-chiral. So you notice this is a methyl group which is non-chiral. Alkene carbon we can ignore. Alkene carbon we can ignore. CH2 carbon we ignore. These 2 carbons are methyl carbon, we can ignore. CH2 ignore. Alkene ignore. CH3 ignore. CH2 ignore. So if we are familiar with this idea, we only need to focus on carbon bonded to 3 groups. There's a hidden hydrogen. Carbon bonded to 4 groups. Most likely this is chiral, but look out for things like this. 2 methyl groups, therefore this is non-chiral. Then very quickly, we will be able to, at one glance, I look across the entire compound, I can identify my chiral carbon. I have 1 cis-trans alkene plus 1 chiral carbon. The total number of stereocenters will be 2. And therefore, the total number of stereoisomers will be 2 to the power of the number of stereocenters. 2 to the power of 2, I'll have 4 stereoisomers for compound Z. Now how about Q? Q after reduction, there's no more alkene, so we actually don't really need to look at cis-trans alkene anymore. We only need to find my chiral carbon. So remember, look out for carbon bonded to 3 things, or carbon bonded to 4 things, or 4 groups. So I have 3 of these guys here. I have 1 chiral carbon here. Remember a hidden hydrogen. I have a chiral carbon here. I have another chiral carbon here. Remember, this carbon is bonded to 2 methyl groups, and therefore this is non-chiral. And I have altogether 3 chiral carbon. Total number of stereocenters will be equals to 3 because there are no cis-trans alkene. Total number of stereoisomers will be 2 to the power of 3, which will give me 8 stereoisomers. All of them are optical isomers because there's no cis-trans alkene here. So we have already identified the number of stereoisomers for Z, which is 4, number of stereoisomers for Q, which is 8. So we can run through the options now. How many stereoisomers exist for Z and Q, Z? There are 4 isomers, Q there are 8 isomers. So the answer to this question is actually pretty straightforward. This will be option B. Alright, so that was the discussion involving this exercise, involving stereoisomerism. So if you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.